Welcome. Linear programming. During installation of electricity bulbs in street lighting, a dealer is required to supply two types of bulbs, A and B. The total number of bulbs should not be more than 400. He must supply more of type A than of type B, and type A should not be more than 300 and type B should not be less than 80. Part A of the question: by letting the number of type A bulbs to be X and the number of type B bulbs to be Y, write all the inequalities representing the above information. Part B: on the grid provided, draw all the inequalities. And then part C: if type A bulbs cost 450 per piece and type B cost 350 per piece, and the higher the cost, the higher the profit. Part 1: use the graph to determine the number in each type of bulb that he should supply to maximize the profit. Part 2: calculate the maximum cost of lighting the street. Now, after going through that, let's go to the first part and we form the inequalities. So we start from here by letting the number of type A bulbs to be X and the number of type B bulbs to be Y. Then we're going to write the inequalities beginning from the second statement. The total number of bulbs should not be more than 400, should not be more than 400. That means the sum, that is type A bulbs and type B bulbs, should not be more than 400. So the sum, the first inequality, will be the sum of the bulbs, X plus Y, that is of type A and type B, should not be more than 400, means should be less than or equal to 400. That is the first inequality. Then the second inequality: he must supply more of type A than of type B. More of type A. Remember, type A bulbs are X, and those ones should be more than of type B. Greater than, more of, that is greater than type B, that is Y. Type B bulbs are Y. That is the second inequality. And then the third inequality: and type A should not be more than 300. Type A bulbs are X, the number of type A bulbs are X, and they should not be more than 300. They should not be more than 300, means that they should be less than or equal to 300. Should not be more than 300 means less than or equal to 300. Then the next one: and type B should not be less than 80. Type B bulbs, the number of type B bulbs are Y. They should not be less. They should not be less than 80. That means they should be greater than or equal to 80. Those are the inequalities from the statements. Then the last one that you can include: these are number of bulbs, X and Y. They should be non-negatives. That means that the number of type A bulbs should be greater than or equal to 0, and also the number of type B bulbs, that is Y, should be greater than or equal to 0, meaning that they should not be negative. They should be non-negative, either 0 or greater than. Part B: on the grid provided, draw all the inequalities. So let us draw the inequalities. So the first one is X plus Y is less than or equal to 400. So X plus Y, so that is the first one. X plus Y is less than or equal to 400. So the line that you are going to draw is X plus Y is equals to 400. So that is the line that you're going to draw, and we are going to use at least 2 points to draw that line. I'll use 2, but you can use the third one for confirmation. So I'll use some few points here. Just 2 are okay for me. So for example, when X is 200, Y will be 200. If you substitute here, when x is 0, then y will be 400. And then it is good to note that this line will be a continuous line. It will be a continuous line by the fact that you can see this sign less than or equal to, meaning when you draw that line, all the points that lie on top of that line will also satisfy the inequality. So let us draw it. So we can first maybe list all the other lines, the points that you're going to use for all the other lines, and then we come to plotting them. So the other one is x is greater than y. X is greater than y. So x is greater than y. The line you're going to draw here is x is equals to y. Choosing points here is quite easy because you simply need to, if you, for example, say x is 100, y is 100, x is equals to y. When x is 200, y will be 200, and so on. 300, 300, and so on. This line will be broken. This will be a broken line, you can see, because of these are greater than, just greater than, meaning that points lying on top of that line would not satisfy the inequality. Then the third one is, yeah, x is less than or equal to. I think this one was less than or equal to, less than or equal to, less than or equal to 300. So that one, x is less than or equal to 300. So the line you're going to draw is x is equals to 300. So this line will be continuous line. Drawing that line is quite easy. And then the fourth one is y is greater than or equal to, y is greater than or equal to 80. The line you're going to draw here is y is equals to 80. Also, this one will be a continuous line. Now let's go to the first line. And the scale, when I look at this point, the scale that I'm going to use is 50. 50 is okay. So let me go to the graph. This is 0. So use 50, 50, 100, 150, 200, 250, 300, 350, 400, 450. So those are the points. And this is type A bulbs, that is X. Then for the y-axis we shall have type B bulbs, that is Y. So here we have 50, we have 100, 150, 200, 250, 300, 350, 400. I don't think we shall go past 400. Can stop it at that point. So the first line, 200, 200, 400. So 0, 400, 0, 400 is here. Then 200, 200 is here. So draw that line. So that is the line, continuous line. So x plus y is equals to 400. 400. Now after drawing it, we need to know the side that you're going to shade. Remember, we shade the unwanted side. So on this line, it is continuous line. We need to know whether we're going to shade the upper side or the lower side. And to do that, we shall pick a point on the lower side, let me pick like 0, 0. I'll pick a point here, 0, 0, and then I will test it using this inequality. X plus y is less than or equal to 400. So I'll pick a point like 0, 0. So when x is 0, y is 0, substitute there, you get x plus y will be 0. 0 is less than or equal to 400. So that side satisfies. So 0 is indeed less than 400. So that means this side where I have picked the point 0, 0 satisfies the inequality. Automatically the other side is the unwanted side. So this side is therefore the unwanted side. You shade it. You shade the unwanted side like that. You shade the unwanted side. That is the unwanted side. That line. So now let's go to the other line. Now the other line is x is greater than y. X is greater than y. So the line you're supposed to draw is x is equals to y. We plot this point 100, 100, 200, 200, 300, 300. That is a simple line. So 100, 100 is here. Then 200, 200 is here. 300, 300. So the point 100, 100 is here. Then 200, 200 is here. So you can draw that line. You just require 2 points, but you can use the third one for confirmation. So that is a line that you're going to have. So that is the line. That is the line. So that is the line. That is x is equals to y. Now that line is broken. Remember, we say the line is broken. So points lying on that line will not satisfy the inequality. So to break that line, I'll simply just do it like that. At least this one will show you that the line is broken. So that line is broken. So that is a broken line. Now let us know the side that you're going to shade. We'll test using a point above this line or below. Maybe I can use this point that is here. Point on this side, or maybe this point 200, 100. Let me test with 200, 100. So 200, 100. I test with that. So substitute. X is 200 and it is greater than, get this, x is 200, y is 100. So y is 100. So 200 is greater than 100. So that side where I have picked this point here satisfies the inequality. So automatically the other side is the unwanted side. So you simply shade this side. So this side of the line, that side is the unwanted. That is the unwanted side. We go to the other line. The other line is here. X is equals to 300. That is a continuous line. X is equals to 300. X is equals to 300 is this vertical line. This vertical line passing through 300. So this line, this is the line. So that is the line. So that is the line. X is equals to 300, continuous line. So which side do we shade? It is less than, x is less than 300, less than 300. So that means we require the left hand side of that line. The left-hand side is the one that is less than. The other side, you can see the values from to the right of 300, 400, 350. We don't require that because we should have less than 300. So that means this side is the unwanted. The right side of that line, we shade the right side of that line like that. We shade it like that. And then we go to the next. The next one is y is equals to 80. Continuous line as well. Y is equals to 80. 80 is here, 50, 60, 70, 80 is this, it is here, 80 is here. So this is a y. So y is equals to 80. So that one, y is greater than is on the upper side of that line. So the side that is below is less than. This is the less than. And therefore, values below that line will not satisfy the inequality. That is why we are shading below that line. Above that line, those values are required because y is greater than or equal to 180. That is above that line is greater than, below the line is less than, and that is the unwanted side, and that is why we've shaded that. You need to shade properly so that you can see this side or this region. I mean the region that is left and shaded is the required region that will satisfy all the inequalities. So this is the required region or the feasible region. So now we have plotted all the lines. We have shown all the inequalities, shading the unwanted sides, and we are left with this required region here that is unshaded. I'm shading all this so that can be clear. So this region that is left here, this region, you can see it, this region is the required region. So part C of the question, if type A bulbs cost 450 per piece and type B cost 350 per piece, and the higher the cost, the higher the profit. 1. Use your graph to determine the number in each type of bulb that you should supply to maximize the profit. Now, to work out that question, we need to know how to optimize. You're supposed to use this graph to determine the maximum profit. That is actually what you're supposed to get the number of each type of bulb, that is type A bulbs and type B bulbs, that will give maximum profit. So you're required to maximize. And this is how we maximize. We need first to get the objective function. So we need to get the objective function, and this is what you're going to use to maximize. Where do we get the objective function? From the statement here. Type A bulbs each costs 450, and there are X number of bulbs of type A. So the profit therefore will be given by each bulb 450 multiplied by the number of type A bulbs. That will give us the profit from bulbs type A, that is X. Then for type B bulbs, they are Y in number, so each costs 350, then times Y bulbs, that is type B. And this is what is going to give us the profit from both type A bulbs and type B bulbs. So from there, we're going to use the search line to determine the number in each type of bulb that should supply to maximize the profit. So how do we draw the search line? This is how we draw it. The easiest way is to find the least common multiple of 450. We are getting 450 from the cost, that is the profit of type A bulb, 450, and 350, that is the cost of type B bulbs. So let us get the LCM. Once you get the LCM, the least common multiple of 450 and 350, that will give, just calculating that one, will give that 150. You'll get that 150. So after getting the least common multiple of 450 and 350, you take the objective function, and this will be 450x plus 350y equate to, now the profit P will be given by that 150, the LCM that you got. Now this is the line that you're going to draw, that you're going to use to either maximize or minimize. In this case, we are maximizing. So to draw this line, of course, you need 2 points. 2 points. So you can start by, when x is 0, substitute in this equation. Y will be that 150 divided by 350, that will give 9. Then when y is 0, when y is 0, that 150 divided by 450, that will be 7. So that is, these are the points that you're going to plot. So when you draw this line, now from there I'll show you how to get the maximum profit. So let's go to the graph. When you look at our graph, look at the scale. 1 centimeter represents 50, and when you plot, you try to plot this one, 0, 9, and 50. This is a 7, 0. This one will be too small, so you'll not be able to see that line properly. So I'm going to adjust these points by multiplying each of them by a constant number. Let's say I multiply each one of these by 20. Let's say 20. So 0, 9. So 0, 9. When I multiply this one by 20, I'll get 0, 180. It will not make any difference. Then 7, 0. Instead of plotting 7, 0, because it's very small, I multiply this one by 20. It will be 140, 0. Now this is what I'm going to plot, and this is going to give me now a good line. So 0, 180, 0, 180, can plot that. So 0, 180 will be somewhere here, So this is a 160, 170, 180. 180 will be somewhere here. 60, 70, 80. To be somewhere there. Then 140, 0. The other one is 140, 0. 140 will be somewhere here. 140 to be somewhere here. So 140, 0. So let me draw that line. So that is the line. So that is the search line. So this is the, that is the search line. So plotted 180, 0, 180 is here. Then 140, 0 is there. Now after drawing the search line, you've noted the process of drawing the search line. Now we need to get the number in each type. The number in each type of bulb that will give maximum profit. So you're going to use a ruler and a set square for this. And this is how you place it. So take a ruler. Simply take a ruler. And then the set square. Make sure that the set square is aligned in such a way that it lies on that straight search line. It lies on top of that such line, like that. Good, like that. Make sure it is like that. And then the ruler, you should place it like this. Make sure the ruler is placed like that. So with the ruler held firmly here, should not move. The set square, this straight edge of the set square is lying on that such line, like that, straight. Then this straight edge of the ruler and the set square, their point of contact is here. The ruler is held firmly. You're just sliding them, the set square. So you slide it along that straight edge of a ruler, like that. You slide it like that. Then I'd like you to check the last point that is touched by that set square as it leaves that region. The last point that is touched as it leaves the region, and it is this point that is here. This point is the one that is touched lastly as the set square leaves the feasible region. So I want you to observe that this point that is here, that point is 300. This point is 300, 100. This is the point that is touched as the set square leaves the feasible region. So look at it again. Just look at it as I slide. Just look at it. So you see, you look at that point. So this is the last point that is touched, the last corner point. This point lies on the broken line, so it will not be used. Point lying on the broken line will not satisfy the inequality. That one cannot give us a solution. These are the corner point here will not. So therefore the maximum profit will be given by this point. This is the last point that is touched as the set square leaves the feasible region, and this point is 300, 100, 300, 100. That is the last point. So we go to the question. So the question is the number in each type. So the point is 300, 100. That is the point. It is here. 300, 100. That is the point. So remember 300 for X, that is the type A. So this is X and this is Y. So type A bulbs, number of type A bulbs which are X will be 300. So type A. So type A bulbs will therefore be, type A bulbs will be 300. Then type B bulbs will be 100. Those are the bulbs that will give us maximum profit. Then the last one is calculate the maximum cost of lighting. Now that we have the bulbs that will give us the maximum profit, we simply need to take the objective function 450x plus 350y is equals to the cost or the profit. And these bulbs that we obtained here, 300, 100, so you just need to substitute them. 450, x is 300 plus 350, y is 100. So use a calculator to work out that. That will give us the maximum cost. So this is 450 multiplied by 300 plus 350 multiplied by 100. That will give 170,000. So therefore the cost is 170,000. 70,000.